Okay, so this video is just going to be talking about the process of solving trigonometric equations. Now, before we really get into this, let's talk. You know, when you solve linear equations, right? We're talking about inverse operations, okay? Going in the reverse order of, please excuse my dear Aunt Sally, when you solve quadratic equations, there is some work with inverse operations, but also this idea that you need to set the equation equal to 0 because you might want to use the quadratic formula, or you might want to factor it, okay? So that it added a new element, right? When we solve trigonometric equations, it's those two things, the idea of inverse operations to try to isolate a variable, okay? Or possibly factoring if you have a quadratic or a higher degree. And then you also have the introduced step of using arc functions. So I'm very opposed most of the time to giving you step-by-step directions for how to do something, because very rarely does it address every single problem. And I'm not going to put my stamp on this and say, if you do these 4 steps, you can solve any trigonometric equation. But for the most part, what we look at, this should work, okay? So the first step says, and I apologize for the small font if you can't see this at home. It says, use substitutions to write the equation in terms of one trig term, meaning all sines, all cosines, or all tangents, okay? Do you have to do that first? Not necessarily, okay? And you're like, oh, you told us this is a step 1. Okay, different problems present different scenarios, but as a general rule, solving a problem that has sines and cosines in the same problem, right? Not going to be as easy. And we're going to talk about all these, right? Okay. Now, I said that if it's possible, you should do that, or you can do that first. And you can have different degrees. What that means is you can have a sine x and a sine squared x in the same problem. That's fine. You would want that, okay? And we'll see some of those. Now, step 2 comes in 2 parts, because what you want to do is you want to isolate the trig term. But if you can't do that, the alternative method is to factor the expression into the product of 2 quantities and set it equal to 0. So in other words, if you can't get an expression, if you can't get an equation to say sine of x equals blah, 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 then you may have to factor and have that product equal to 0. It would look something like that, right? Or maybe you have a term that you factor out, where you have something on the outside times a quantity set equal to 0, okay? Where you have a product here. It could be the product of 2 binomials. It could be the product of a binomial and a single term. We'll see instances for both. Now, once you've done this, and you've isolated the trig term, or you've shown this product equal to 0, and then you separate using the 0 product property, use your arc functions that we learned about from chapter 4, or in unit 4. Arc sine, arc cosine, arc tangent, right? Arc functions are the same as inverse functions, right? So we have arc sine. Arc sine can be replaced with inverse sine. But many of the problems that we're going to do here in class can be done using the unit circle and our arc sine function, arc cosine, arc tangent. And then we use the coordinates of the unit circle to evaluate the arc function. Okay? So that's the 4 ideas there. Now, this is, or the 4 steps. This is kind of going to mess with us a little bit. I'm going to address that once we actually get to solving one of these, okay? Because if you recall, and you should recall this, even though it's been a while, arc sine, if you remember, we were only allowed to use the angles that were in quadrants 4 and 1. And we used negative angle measurements down here for those values. Like instead of this being 11 pi over 6, we called it negative pi over 6, okay? And then we used the positive angles in the first quadrant. That was specifically for arc sine. What we're doing now, we're allowed to use the entire unit, the first period of the unit circle. And we're allowed to use positive angle measurements. Okay, and again, we'll address that when we get to it, when we're solving that. One last thing before we end this introduction. You're going to be tempted at times to divide out trigonometric terms. So when you look at this, and you say, okay, how do I set this, how do I isolate cosine? Okay, now, don't write this down. But some of you may look at this and be like, well, if I do this, because now we're solving, we're not verifying, right? Now the question is not, are these the same? The question is, these are the same, solve for x. It's kind of a step away from what we've been doing, right? Some of you are going to be tempted to do that, and what will happen is one of these cosines will cancel with this cosine, right? And that'll equal 1, and dot, dot, dot. Okay, you're going to be very tempted to do this. You cannot. You cannot. Okay, here's why. This is still a second degree of our variable of x, and the fundamental theorem of algebra, if you recall, said that an equation has as many solutions as its degree, more or less, right? So when I have an equation that's, the solutions to this equation are positive 1 and negative 1, right? Two solutions. There's going to be a time where factoring this, by dividing here and canceling, you're eliminating one of your solutions. And you can't do that, okay? So, take my advice for it now. When it comes up again, I'll bring this up. But you cannot divide by a term that would cancel it completely from the equation. You cannot do that, right? What would you do? Right? In a situation like this, because this is quadratic, not to get too far ahead of ourselves, but because this is quadratic, we would subtract this over here to make sure that it was set equal to 0. Because that's how we solve quadratic equations, by setting them equal to 0. This is a quadratic trigonometric equation. Okay, so this is how we would approach this problem. But we're putting the cart before the horse right now. Let's do a couple of simpler ones first before we get to that. Okay?